Welcome to Dr. Carmenatty's YouTube channel, your go-to channel for everything related to technology and its intersection with everyday life. Today, we're going to dive into a compelling topic that sits at the very core of how technology is revolutionizing our world. This topic combines AI, operations, and the growing need for efficiency and scale in deploying advanced models. If you enjoy what you hear, don't forget to like, share, comment, and subscribe to join our growing community as we explore these fascinating subjects together. Today, we're going to answer a few questions that will clarify the future of AI implementation. First, what exactly is MLOps? How does it compare to the emerging concept of FMOps? And finally, what are some practical use cases for FMOps, specifically in fields like cybersecurity, health, and the military? By the end of this video, you'll have a solid understanding of these operational methodologies and why they matter so much to modern AI deployments. What is MLOps? Let's start by talking about MLOps. MLOps, or machine learning operations, is essentially a set of practices designed to bring the entire life cycle of machine learning projects into a smooth, well-organized, and effective pipeline. Think of it as the union between data scientists, machine learning engineers, and operational teams, working in harmony to get machine learning models from the experimental phase into real-world production environments. It's about taking that brilliant algorithm you developed in a Jupyter notebook and getting it out into the wild where it can actually start making decisions, responsibly and efficiently. The world of machine learning can be pretty challenging, with several moving parts. There's data gathering, pre-processing, model development, validation, testing, deployment, and even ongoing monitoring for performance and ethical compliance. MLOps takes a holistic view of all these components and stitches them together into an operational framework that can scale, automate, and manage the complexity involved. A simple analogy would be the process of building a car. Designing the model is one thing, but getting it onto the road involves a whole host of other considerations, like safety tests, assembly lines, and quality checks. MLOps is the assembly line for machine learning models. It helps ensure that models can scale to meet demand, remain efficient, and continuously learn and adapt to new data while staying secure and compliant. What is FMOps? Now, let's shift our focus to something newer and potentially even more transformative: FMOps, or foundational model operations. FMOps build on the foundational concepts of MLOps, but aims to manage the lifecycle of much larger, more complex AI models known as foundational models. These foundational models are typically massive, pre-trained models like GPT-3, BERT, or other similar AI systems that serve as a base upon which more specialized models can be adapted. In many ways, FMOps is the logical evolution of MLOps to deal with the new challenges that these large-scale foundational models bring to the table. Think of foundational models as raw diamonds, precious but requiring a certain level of operational polish to be adapted to specific use cases. FMOps isn't just about getting a model into production. It's about efficiently managing these enormous, pre-trained models, fine-tuning them, and deploying them across multiple domains and applications. Foundational models are often general-purpose models, pre-trained on vast datasets and then adapted for specific use cases. Because these models are so big and so general, FMOps deal with issues that MLOps typically doesn't face, like managing compute resources efficiently, securely handling model retraining on specific, sometimes sensitive datasets, and even keeping track of the ethical dimensions and biases that might be amplified given the scale at which these models operate. In a sense, FMOps is MLOps on steroids. It scales everything up to deal with much larger datasets, models, and use cases. How does MLOps differ from FMOps? It's important to understand that while MLOps and FMOps share similar principles, like aiming for operational efficiency, scalability, and reliability, they differ in scope, scale, and execution. MLOps is primarily about getting traditional machine learning models into production. It focuses on integrating machine learning models into business workflows, ensuring automation repeatability, and minimizing errors during deployment. FMOps, on the other hand, operates on an entirely different scale. We're talking about models that require substantial computing resources, often involving millions, if not billions, of parameters. The operational requirements are heavier, the data governance considerations are broader, and the stakes, mainly when these models interact with sensitive fields like law, medicine, or cybersecurity, are much higher. Whereas MLOps might work with a moderate-sized dataset, FMOps have to grapple with datasets that represent the breadth of human knowledge. To put it in perspective, if MLOps is like managing a well-curated library, FMOps is like being responsible for an entire national archive. The goals are similar, to allow efficient access and use, but the scale and complexity are vastly different. Use cases for FMOps, cybersecurity, health, and military. Let's explore three key areas where FMOps could bring a revolution: cybersecurity, healthcare, and military operations. We'll also compare how FMOps would add value beyond what traditional MLOps offers. In cybersecurity, MLOps can automate tasks like identifying patterns in network activity that suggest malicious behavior. It's useful, for example, in developing models that detect phishing emails or flag suspicious login attempts. With MLOps, the focus is on deploying these models to stay one step ahead of cybercriminals. With FMOps, however, you could harness the power of foundational models to provide a more comprehensive defense strategy. Imagine a foundational model trained on a vast dataset of all publicly available cybersecurity incidents. Such a model, fine-tuned to an organization-specific data, could not only detect threats but also predict potential vulnerabilities based on real-time threat intelligence. The ability of foundational models to generalize across different domains means they could incorporate lessons from incidents worldwide and adapt them to local networks faster and more holistically than a specialized MLOps model. In healthcare, MLOps has been instrumental in automating diagnostics, developing predictive models, and even personalizing treatment plans based on patient data. For example, a hospital could use MLOps to deploy a model that predicts patient outcomes based on existing medical data. FMOps take this a step further by utilizing foundational models that understand a much broader spectrum of health-related information. Imagine a foundational model pre-trained on global health datasets, medical research, and patient records. When fine-tuned for a specific health provider, this model could offer diagnostic support that not only looks at local patient data but incorporates global best practices, recent research publications, and evolving medical knowledge. Essentially, FMOps allows for a greater breadth of information to be applied in real time, making diagnostics and treatment much more effective and dynamic than a localized MLOps solution. In military applications, MLOps might be used to deploy models for threat detection, autonomous drones, or optimizing logistics. The scope here is often tactical, deploying individual machine learning models for particular applications like recognizing enemy vehicles from drone footage. With FMOps, foundational models can be used to enhance decision-making at a strategic level. Imagine a foundational model trained on vast amounts of geopolitical, historical, and social data, fine-tuned for military intelligence purposes. This model could not only assist in identifying threats but also predict the consequences of different tactical maneuvers, taking into account global political climates, historical precedents, and cultural factors. FMOps here move from operational efficiency to strategic depth, providing insights that are far beyond the capability of a specialized MLOps system, effectively becoming an advisor that informs military decisions on multiple fronts. MLOps and FMOps both offer ways to bring machine learning models into the real world effectively, but they differ significantly in scope and impact. MLOps makes AI deployment manageable and repeatable for businesses. At the same time, FMOps elevate the game by managing foundational models that are complex, large-scale, and able to generalize across a wider variety of tasks. We've looked at how MLOps and FMOps differ and explored the use cases in cybersecurity, healthcare, and military operations, illustrating how foundational models can revolutionize these fields. FMOps' ability to take pre-trained models and fine-tune them to specific needs brings us closer to realizing AI's full potential across different domains, making it an exciting development in the world of AI operations. If you found this discussion informative, please share your thoughts in the comments. We would love to hear your questions, opinions, or experiences. Don't forget to like this video if you enjoyed it, and subscribe to Dr. Carmenatty's YouTube channel for more deep dives into technology and its applications to our daily lives.